Maths Solving Linear Equations tutorial video. In this video, we are going to try and solve equations with unknowns on both sides. We want to be able to isolate the unknown by applying the same function to both left and right hand side of the equal sign. And we want to be able to check the validity of solutions by substituting our value back into the original line of the equation. And as part of solving equations with unknowns on both sides, we have to ensure that we can already solve two-step linear equations. So maybe at this point, if you're unsure whether you can do that or not, go back and check the objective that is named two-step linear equations. First of all, let's look at the idea of equality and how we can model equality and solving equations by using algebra tiles to make sure we fully understand this process. So if I was to model the equation 3x plus 3 equals x plus 11, I can model it using algebra tiles as follows, where the green rectangular tile is a model of 1x and the yellow square tile is a model of 1. Hence I have 3 green and 3 yellows to indicate the 3x plus 3, etc. What I would like to do is I would like to isolate 1x, and to isolate 1x I must try and get 1x on its own on either the left hand side or the right hand side. In this case I'm going to choose the left hand side. So as I can see, the issue I have is I have numbers on this side that I don't want to be there. So how can I remove those numbers? Well, I can make them 0 by adding in -3. And right now, because I've only applied a function to one side, my equation has become unbalanced or unequal, so I must do the same to the right hand side. So as I can see, I now have 0 pairs. I have +3 and -3, which makes 0. And over here I have -3 and I have a +3 that I can pair up to make 0. Now I'm faced with a situation where I have a 1x on the right hand side that I don't really want to be there. So to remove it or make it 0, I shall add in a -1x. And again, like before, to keep it balanced and equal, I must do the same to the left hand side. And like before, I have 0 pairs. And we can see now that I have 2x is equal to the right hand side, which in this case is going to be equal to 8. So what would I like to do now? I would like to share out equally the two 1x's. And this way I can see that each 1x would be equal to 4. So this idea of sharing equally is like the concept of division when we solve equations. So let's look at how we do this symbolically. So let's look at this example here where we have 5x minus 2 equals 3 plus 4x. And in this example on the left hand side, I would like you just to watch and observe, make notes, and then I'll give you the opportunity to pause the video and try one of your own. So in this question, I'm going to stick with the procedure of isolating 1x on the left hand side. So I can see that I have a -2 that I would like to really remove. So I'm going to add 2 to both sides. And I'm taking care to line up my numbers that I'm adding in with the numbers that exist in the equation already. So in this case, what's going to happen is I'm going to be left with 5x equals 5 plus 4x. Now, very much like the previous example, I have 4x, which will be like the 4 green tiles that I want to remove. I don't want them to be there because remember, I want to isolate 1x on its own on the left and simply just have integers or numbers on the right hand side. So I would like to remove it, and how would I remove it? Well, I would have to add in 4 red tiles. And how do we model that symbolically? Well, I'm going to add in -4x. And again, to keep the equation equal, applying the same function to both left and right, I do the same to the left hand side. And now I can see that I'm quite nicely left with 1x equals 5. And at this point, I can do a nice check and substitute 5 in for x to check that my answer is correct. So what I'll offer you is, if you guys can try this one, and at this point pause the video as I will go through and talk through the solution. So you can pause the video, try it yourself, and check your solution with my solution. So to solve this equation, like before, we're going to add 3 to both sides, which leaves us 6x equals 7 plus 5x. Now I have that positive 5x that I would like to remove or make 0. So I'm going to add in negative 5x to both sides, which leaves me 1x equals 7. So I've isolated the 1x, and that is equal to 7. And I can check by substituting 7 back in to check my equation holds true. So let's look at a slightly different example. This time the question looks minimally different, but as you'll see, the solution steps are slightly varied in the way we solve this one. So if we take a look at the equation, let's analyse what's going on. Remember our thought process, we want to isolate 1x, and again in this case we're going to try and isolate 1x on the left hand side. So I can see a good starting point would be to start on the left and tidy up the left to make sure I don't have anything else there except for x terms. So I have this negative or minus 11 as it's put down there, but it's a negative 11. So how do I make that go to 0? Well, I'm going to add 11 to both sides. And as I can see here, that will leave me 5x equals 21, because I've added 11 to the 10. And I've still got the minus 2x on the right hand side, which to remove, this time I'm going to add positive 2x to both sides. And now that is going to leave me 7x equals 21. Now in the very first example that I modelled with algebra tiles, you'll remember I had the situation where I was faced with 2x was equal to 8 and I had to share the 8 amongst two groups. So this idea of sharing or dividing into two groups, we're going to model by saying I have to share into 7 equal groups, and we're going to model that by saying multiply by 1/7. On some occasions, you might have been taught to write divide by 7. That is also fine, but we're going to stick with this model of multiplication. Both methods you'll arrive at the same solution. So let's divide 7 x's into 7 equal piles, which means we would have 1x in each pile, and we're going to divide 21 into 7 equal groups, and in each group we would have 3. So I will allow you the opportunity now to try one on your own. Again, this would be the point where you would pause the video and check your solution against my solution. So in this question we're going to add 20 to both sides, which leaves us 3x equals 30 minus 2x. I'm now going to analyse and evaluate what I have left, and I can see this negative 2x. I wish to add 2x to both sides, which means I now have 5x on the left hand side and only 30 left on the right hand side. So again, I want to share into 5 equal groups because I want to isolate 1x. And how do I model that? Well, I say I'm going to multiply by 1/5 and do the same to both left and right. 5x shared into 5 equal groups will be 1x. 30 shared into 5 equal groups is this idea of division. We're sharing into 5 equal groups, so we end up with 1x is equal to 6 for this equation. The last question, we can see we're faced with the same type of equation, but let's look at the solution steps and how they may differ on this question. So like before, let's start on the left hand side of the equation, and we can see we have this negative x that we would quite like to make 0. So let's add positive 6 to both sides, taking care to line up with the numbers on each side. It wouldn't make sense to put positive 6 underneath the 5x because they can't be added together. On our next line, we're going to be left with 3x equals 5x plus 24. And now if from before we want to remove this 5x because we're quite happy with numbers being on the right and we want to isolate the 1x on the left, so we can read off a solution 1x equals something. So we've got a positive 5x, so we have to add negative 5x to the right and also to the left. And now we have 3 plus negative 5, which we should know from our work on directed number is negative 2x, and we have 5 plus negative 5, which is 0, which would be like 5 green tiles and 5 red tiles making 0 pairs, and 24 is unchanged. Now, like before, we want to share it into two equal groups, and we want to deal with the negative at the same time. So what I can do is I can share it into two equal groups, which would be like multiplying by 1/2. But I also want to flip the tiles, if you think about it in that sense, or do the opposite of, which means I multiply by -1/2 to both left and right, which means I now have 1x is equal to -24/2, and performing this simple simplification of the fraction or division, if you think about it mentally, would leave us with x equals -2. So I'll give you the opportunity to try one that is slightly different, and you would pause the video here and check your solution with my solution in a couple of minutes. So to solve this equation, we would again begin on the left hand side and look to see that we want to isolate 1x, and this one looks slightly different because we have a negative, but if we stick with our procedure, we have a +7 that we want to remove, so we're going to add -7 to both sides, which leaves me -3x equals 12 minus 5x. The -5x is something I don't want to be there because I want to isolate the 1x on the left hand side. So let's add 5x to both sides. So +5x on both sides, which is going to allow me to do some zero pairs here. So I've got -3, +5, which leaves me +2, and that is equal to 12. Again, like before in the previous example, I have to split into two equal groups to get 1x isolated on its own. So I multiply by 1/2 on both the left and right, which leaves me x equals 12/2, leading to x equals 6. So hopefully that's made sense, and what I would like you to do now is to try and answer some of these questions. You can choose as many as you like or do all of them, and if you pause the video at this point, you can try and work on them on your own, and if you unpause the video, you will see that I will offer the answers to check once you have completed them. So thank you very much for watching our tutorial video, and hopefully this has made sense to you and you'll understand how to solve linear equations with unknowns on